This video is over lesson 87, multiplying algebraic terms, and it is for my 7th grade math class. So remember that to add or subtract terms, they must be like terms, meaning they have the same variables. This is because addition and subtraction are the weakest operations. So just like adding and subtracting fractions, we have to have a common denominator. Adding and subtracting terms, we have to have the same variables, common variables. However, because multiplication is stronger, we do not need to have like terms in order to multiply terms, just like you don't have to have the same denominator to multiply fractions. There are 4 things that we need to keep in mind when multiplying terms. So these 4 rules are going to help us to simplify. So first is the product of powers rule, and this is the one that says x to the power of a times x to the power of b equals x to the power of a plus b. So powers multiplied together with the same base, so we've got to have the same base, can be combined by adding their exponents. So 10 to the 5th times 10 to the 7th is really 10 to the 5 plus 7, or 10 to the 12th. Our next rule is called the power of powers rule. So the power of powers rule says I have x to the power of a, and then I raise that to the power of b, then this is x to the power of a times b. So when a power is raised to a power, the expression can be simplified by multiplying the exponents. So x to the power of 5, then raised to the power of 7, is really x to the power of 5 times 7, or x to the 35th power. Next up, we have the power of a product rule. So there's my product, and I'm taking a power of the product. So x times y to the power of a is the same as x to the power of a times y to the power of a. So a product raised to a power is equal to the product of the factors raised to the same power. So if I have 3x and then I square it, this is equal to 3 squared x squared, which of course then 3 squared can simplify to just 9, so 9x squared. And then finally, the last thing that we have to keep in mind isn't so much a rule as much as it is we just need to understand what things mean. So, for example, exponents only apply to whatever they are directly next to. So if we have a negative x squared, this exponent is directly next to this x, just the x. So if we were to expand this square here, this 2 exponent, is telling me to multiply x with itself. So it would be x times itself, but the negative is just hanging out there. So that negative will tag along to the answer, and we'll back to a negative x squared. However, if I put parentheses around that negative x, now the square is happening to the entire thing that's inside the parentheses. So this is now telling me to multiply something with itself. Well, what's that something? Negative x. So it's telling me to multiply negative x with negative x, which of course a negative times a negative cancels out and leaves me with just a positive x squared. So if I put this in terms of numbers here, if I have a negative 3 squared, like this, well, this is really just 3 squared. The square is telling me to do 3 times 3. So it'll be 3 times 3, and the negative just is there. Well, 3 times 3 is 9, and it'll be a negative 9. But if I put the parentheses around it, now it's telling me to square negative 3. So this will be negative 3 times negative 3, and a negative times a negative is a positive. So we got to kind of keep that in mind as we work through this a little bit. All right, let's give it a shot. So we're going to look at the practice problems. We are on page 600, page 600. A says find the following products, show and justify each step. Well, first I'm going to copy the problem down. So I've got a negative 3x, and in parentheses a negative 2xy. The purpose of the parentheses here, ladies and gentlemen, there's two purposes here. One is this is one way to show the multiplication, because when we got something in parentheses next to something in parentheses, that means multiply. The other purpose here is to identify your different terms that you're multiplying. So I have a negative 3x as my first term that I'm multiplying, and then my second term that I'm multiplying is a negative 2xy. So the parentheses here don't really tell me to do anything first. They're just grouping things together and saying to multiply. So what's the reason for this? Well, it's the problem that you were given. Now, like we did in a previous lesson here recently, we are going to use the associative property of multiplication. Oop. And that's a title, so that should be a capital M for multiplication. Associative property of multiplication will allow us to change the associations. So I can change this so this becomes a 3, a negative 3, and then times x times a negative 2, and I'm going to use parentheses there just to make sure that's clear, times x times y. And so that kind of breaks it up into its pieces there. Now it's been broken up into its pieces. We've changed the associations. We've changed where the parentheses were. Now I can come in and use the commutative property of multiplication. If I use the commutative property of multiplication, I can go ahead and rearrange these, move these around, have them travel so that my two numbers are next to each other. So I'll have a negative 3 times a negative 2. And then I can rearrange these so my x's are next to each other. So I'll have an x times x. And then, well, we'll just have a y there at the end. Now if I use the associative property again, this time to put parentheses back in, well, I can say I'm going to do my negative 3 and my negative 2, and then I'm going to times that with my x times x, and then we'll just have y. Well, negative 3 times negative 2, and negative times negative is a positive, so that's a positive 6. X times x, remember that when we multiply things with the same base, we add their exponents. So this is really x to the first power, and this is x to the first power, so 1 plus 1 is 2. That's x squared, and well, y is just there. And so when we simplify, that's my answer. So that's what it looks like to justify your steps. All right, we're going to take a look then at B. For B, I have 3x squared, and then parentheses x, y cubed. And so this is the problem that was given to me. I'm going to use my associative property just as I did above. So I'll have 3 times x squared times x times y cubed. And actually, as I look at this, everything seems to be right in order the way I would want it. So I don't really need the commutative property here. So actually, using the associative property, we can just say, since we're using it, just change the parentheses around there so we put the x's together since they're already next to each other. That's all I really need there for B. And so now we're going to go ahead and simplify it. So I'm going to have 3, because that's my only constant, that's my only number. And then x to the second power times x to the hidden 1 power. Well, 2 plus 1 is 3, so that's x to the power of 3. And then y to the power of 3 when I simplify. So that one was a little shorter. Taking a look at C, we have 2a squared, And then in another set of parentheses, negative 3ab cubed. So that is the problem that we were given. Now I'm going to use the associative property of multiplication. Oh, forgot property. Associative prop for property of mult for multiplication will allow me to break this up into pieces. I'm going to put that negative 3 in parentheses just so it's clear. It's a negative 3, not a minus 3. And now the commutative property will allow them to travel so that way I can match up things that are similar or the same. So I'm going to put my 2 with the negative 3. Then I'm going to have my a squared and my a, and then my b cubed. Finish it up by putting in the parentheses again to group like things. So 2 times negative 3, I'm going to go ahead and let that be there, times a squared times a times b cubed. And finish it off by simplifying. Simplify. So 2 times negative 3, 2 times 3 is 6, but the negative will tag along, making that a negative 6. A squared times a, so that's got a hidden 1 exponent, so 2 plus 1 is 3. So a cubed, and then b cubed. So negative 6, a cubed, b cubed. D, I have a negative 4x times a negative 5x squared y. That's the problem that I was given. So the associative property will allow me to drop the parentheses and rearrange the associations. So I've got a negative 4 times an x times a negative 5 times an x squared times a y. Now to commute, commutative property, remember commutative means to move, to travel, commute. So I'm going to have the negative 4 and negative 5 commute next to each other. I'll have the x and the x squared next to each other, and then y will hang out by himself. Put in some new associations, some new parentheses to group things that are similar. And so I'll have my negative 4 and my negative 5, which really I didn't need parentheses there. I could have just left that alone, but that's all right. And then I do want to group my x's together, and then, well, y is all by himself. So I'll finish it off. 4 times 5 is 20, but 2 negatives will cancel. So that's a positive 20. X to the power of a hidden 1 times x squared will be 1 plus 2, so that's x to the power of 3. And, well, y is just there when I simplify. And that's D. Moving on to E. Find each product by multiplying the numeric factors and gathering variable factors with exponents. So this time, ladies and gentlemen, we don't have to justify our steps, and when we don't have to justify our steps with properties, things tend to go much faster. So this is going to go a good bit faster. I have a negative xy squared times xy times 2y. So this time I'm just going to put an equal sign there and we're going to go for it. So when we don't have to show our each individual step and justify our answers, we're going to go a little faster, and so we're going to start by multiplying all the numbers together. So remember, any time that we don't have a number in front, that's a hidden 1. And since this is a negative, this is really a negative 1. So I have a negative 1 for my number, another hidden positive 1 this time, and then a 2. So 1 times 2 is 2, but then this negative will tag along, making it a negative 2. Then I'm going to put together my variables, but I'm going to do one variable at a time. So let's start with our x's first. So I have x times x, and then, well, no x's. So really just x times x. Well, 1x times another x is going to be 2 x's, x squared. Then do your y's. So y squared times y times y. Remember, we can, when we multiply powers, we can add their exponents. So this is a hidden 1 exponent. This is a hidden 1 exponent. So this is really 2 plus 1 plus 1. Well, that's y to the 4th. And so when we don't have to justify our steps, you can see it goes much, much faster. F. Negative 3m times a negative 2mn, and then times m squared n. So again, we're going to start with the numbers, and then we'll move on to the variables one at a time. So the number here is a negative 3 times a negative 2. So negative 3 times negative 2, it would be a positive 6 because the two negatives would cancel. And then this is a hidden 1. So 6 times 1 is, well, just 6. So 6 is my number. Moving on to my m's. M times m squared. So a hidden 1 exponent, a hidden 1 exponent, and a 2 exponent. So 1 plus 2 would be m to the 4th power. And then finish it off with the n's. No n's there, but this has an n times an n. Well, that's n squared. So 6m to the 4th power n squared. G. G says 4wy times 3wx times a negative w squared, and then times x squared y. So start with the numbers. 4 times 3 is 12, times a negative hidden 1. Well, 12 times 1 would be 12, and then negative would make that a negative 12. And then a positive 1 will still make that a negative 12. And typically we like to go with our variables alphabetically. So I'm going to start with the w's. So I got a w times a w times a w squared. So 1 w here plus a second w here plus 2 more is a total of 4 w's. Moving on to my x's, none here, but I have an x, none here, and then I got an x squared. So 1x there plus 2 more x's there is a total of x cubed. So remember, when we multiply the powers, we add their exponents. So the hidden 1 exponent plus the 2 exponent makes a 3 exponent when we multiply. Last of all, y's. So I got a y here and a y there. Well, y times y is just y squared. So my answer is a negative 12, w to the 4th power, x cubed y squared. H. H says 5d, so even though that's not in parentheses, that's my first term here, times negative 2df, and then times that with a negative 3d squared fg. Numbers first. 5 times a negative 2, well, 5 times 2 is 10, and the negative will tag along to make that a negative 10. Times that by a negative 3, so 10 times 3 is 30, but then the negative that I already had with this negative will cancel, so that's a positive 30. Or another way of looking at it, 5 times 2 times 3 is 30, and then the two negatives will cancel. I like to go alphabetically, so I'm looking at my d's first. So d times d squared. So I got a hidden 1, and a 2. We add those exponents, 1 plus 2. This is a d to the 4th power. Look at my f's. I don't have any f's. I got 1 here, I got 1 there. Well, f times f is f squared. And then finally for my g's, well, I've only got the 1. So, well, I'll still just have the 1. So 30d to the 4th f squared g. And then finally, I. It asks us to simplify this with showing two different methods. So here we go. I'm going to do 3x y cubed squared. So one way that we can do this is we can go ahead and expand that exponent. So I can make this 3x y cubed times another 3x y cubed. And so if I do this, then I'm going to have a 3 times 3 is 9. I'm going to have an x times x is x squared. And then an x cubed times an x cubed, well, 3 plus 3 is 6. That's one way. Another way that we can do this is by using the power of a product rule. So that if we're multiplying things together and then we raise them to a power, we can split this apart so that each thing we're multiplying together, each of the factors, is raised to the same power. So down here I can split this apart so that this becomes 3 squared times x squared times y to the 3rd power squared. So now if I simplify that, 3 squared is 9, x squared is just x squared, and then if we remember our power of powers rule, a power to a power, we multiply the exponents. So that means down here, y cubed and then squared is really going to be 3 times 2, or 6 for the exponent. So same answer either way, two different methods. You can either expand it and multiply, or you can actually make each one of these things to the 2nd power and simplify. But that, ladies and gentlemen, is the end of our lesson.